while the next talk is from the Dimitris Sakellariou and Tsambouraki Kraounaki, Offshore Geomorphology and Seismic Profiling Data Indicate Active Extension, Transtension, and Strike-Slip Tectonics in the Aegean Region. Dear Dimitris, take the floor.
Thank you very much, Spiros, and many thanks to the organizers of this very interesting workshop. Well, the aim of this presentation is to display some old but also new data on the geomorphology and geophysical structure of the area of the Aegean, and then try to extract conclusions on the style of deformation of the Aegean back arc area. As we know, around the globe there are many back arc areas, and some of them are characterized by extensional deformation, some other display compressional deformation, while there is also back arc areas where we see transtensional or even transpressional deformation. So at the end of this presentation, we will suggest that the deformation in the Aegean back arc area is mostly dominated by horizontal shearing in northeast southwest direction. So let's move on. And okay, we have seen these maps with the GPS vectors and the let's say flow of the Aegean area, the stretching of the Aegean back arc area towards south-southwest. So according to these geodetic surveys, the area is characterized by textural strike-slip tectonics, mostly along the North Aegean, Marmara Sea, and along the Kefalonia transform fault. There is a sinistral strike-slip tectonics along the Strabo and Pliny trenches in the southeastern part of the area. There is the north-south or north-northeast, south-southwest extension in central Greece, like the Gulf of Corinth, for example. And also, geodetic studies have recognized a kind of rigid block that exists in the central southern Aegean that also includes Peloponnese, which is supposed to translate with almost no internal deformation towards southwest. So a very recent paper by Briol et al. Has also tried to quantify lateral movements along the North Anatolian fault in the Aegean Sea, but also along the Movri and the Katuna strike-slip faults in western Greece. And the new thing is that they recognize also a textural transtensional motion in the South Aegean, and actually between Amorgos and the Astipalea Islands. And this transtensional movement is in a northeast southwest direction. And this is, I think, the first time that such a movement has been recognized geodetically. In terms of seismicity and fault plane solutions, things are really clear in the North Aegean, where textural strike-slip dominates along northeast southwest striking faults and fault zones. Also, the textural character of the Kefalonia transform fault is evident, and the sinistral character of the Strabo and Pliny trenches. And then the dominant knowledge is that we have an east-west extension and northwest extension in South Aegean. So as early as in the 90s, we had the expression of the two major hypotheses on the deformation pattern of the Aegean. The one of Armijo et al., which suggests that fast extension is taking place at the terminations of the North Anatolian fault branches, and slow extension takes place in areas in zones which run parallel to the arc, these yellow zones here. And the other hypothesis, which was expressed by Musk and Martin, says that the Aegean region is broken in slabs, in blocks, which are oriented in northeast-southwest direction, and they are separated by strike slip zones or oblique zones, which control the deformation and the stretching of the Aegean. So let's see the Aegean itself. So this is the newest bathymetry or digital terrain model of the seafloor of the Aegean, as conducted in the framework of EMOTNET bathymetry project. This is the right map here, and then in the left, we can categorize the bathymetry classes in the Aegean Sea. So we can see that something like 27% of the Aegean is shallower than 120 meters, while 90% of the Aegean is shallower than 1,000 meters, and only the 10% of the Aegean Sea is displays depths between 1,000 and 2,500 meters, and with the deepest depths occurring in the southeastern part and the southern parts of the Aegean Sea. This is a slope map here, and we can see that something like 70% of the area is a flat, displays flat seafloor, and this includes shelf and basins. And if we add on the map the basins, the actual basins, independent of what depth they have, then we see that the basins represent the 12 or 13% of the total surface of the Aegean Sea. And they are, of course, they are surrounded by the slopes, steeper or less steep. And we can see, if we put on this map the active faults that we have mapped in the area, that the steep and less steep faults coincide with the slopes of the area. That means that there is a genetical relationship between the presence of the basins, the development and the development of the slopes with the active faults, which was expected. Let me say that the orientation of the slopes and the faults as well is mostly northeast-southwest. Then a second category is northwest-southeast, and there is a third category which runs east-west. So what we did is we exploited the available data in the literature from the early days until very recent, and we also processed and reprocessed and interpreted the available seismic profiles, which are in the database that we keep in the Hellenic Center for Marine Research, in order to map active faults and also the post-Miocene sedimentary basins in the Aegean. So I will skip the North Aegean Sea because it is there. It is well constrained that extensive dextral strike slip along northeast-southwest striking zones is well proved. And I will move on directly to the South Aegean, where the situation seems to be more vague. The blue map shows the bathymetry of the South Aegean Sea. You see the depth contours every 100 meters. These are the thin black lines, and every 500 meters, the thick black lines. And what we can see is that the area is characterized by the occurrence of isolated basins and also by elongate ridges. Basins may have different shapes, may be elongate, may be spindle shapes, or kind of irregular shape. The thing is that we observe here that the morphological directions again focus on three categories, which are: the main one is the northeast-southwest one, the second one is the northwest-southeast one, and the third one is the east-west direction of morphological features. And this is also verified by the slope map of the South Aegean here at the bottom left. So we came up with this map that displays the active faults in the South Aegean Sea as derived from the interpretation of literature data and also recent surveys in the area, and also with the occurrence of sedimentary basins. These are the yellow flakes, which are scattered in the South Aegean Sea. So you see there is no, let's say, extended back arc basin in the reality. What we observe here is a pattern of isolated basins, both morphological and sedimentary basins, which are scattered in the area in a, let's say, more or less irregular way. If we move on to the geophysical data and seismic profiling data from the early days, this is a site that was drilled in the 70s in the framework of the deep sea drilling project. This is site 378 in the South Aegean Sea, somewhere between Heraklion, between Crete to the south and Santorini to the north. And this site penetrated for a bit more than 300 meters below the seafloor and met two prominent unconformities. The lower one is the Messinian, which marks the top of the Messinian evaporites below that, and the Pliocene sediments on top of it. And the second one is the one with the blue line, is an unconformity which was dated somewhere in the boundary between Pliocene and Quaternary. So interestingly, this second unconformity, the Pliocene Quaternary unconformity, can be observed in almost all basins in the South Aegean Sea. This is a collection of seismic profiles from the publication of Barthollet et al. In 1983. But you can also see other papers like the ones of Rossi, Maskell and Martin, Piper and Perisoratis, and others, which provide strong evidence for an unconformity in most of the basins in the boundary between Pliocene and Quaternary, or somewhere there. As you know, chronological constraints are really not very strong, but it seems that this blue unconformity is somewhere in the boundary between Pliocene and Quaternary. So recently we completed a survey in the area of Santorini, Amorgos, Astypalea in the central southern Aegean Sea. And we came up with this nice morphological map, which says us that this Santorini Amorgos zone is a morphologically composite one. It includes 7 smaller basins, and which are, for example, this Anidros, the Anafi, the Amorgos South, the Amorgos North, the Kinneros Basin, Astypalea North, etc., which are separated by steep slopes and also by 2 ridges. The one is this one, is Astypalea Ridge, and the other one is this Anidros Ridge. So this interesting and complicated morphological configuration has been also surveyed with seismic profiles, and this is one profile crossing the zone from Amorgos to the north to somewhere close to Astypalea to the south. And this displays again this unconformity, which here is shown in red color, which exists in all basins, or almost all basins of the zone of the Santorini Amorgos zone. And this separates 2 different phases of evolution of the basins. The early phase below the unconformity, this is the one which includes units 4, 5, and 6, 4, 5, and 6, etc., shows something like a single, unified basin with symmetrical subsidence. The later phase, the one above the unconformity, displays enhanced subsidence along the south-facing faults, and also new faults that have been created and deformed the other part of the basins, and also gave rise to ridges that broke the earlier basin and have given rise to new sub-basins. If we put all the faults on the map, then we came up with this fault network in the area, where we have major faults running northeast, southwest, like the Amorgos fault, like the Eos fault zone, like the Anidos Ridge South Zone, the Astipalea Ridge Fault Zone, etc., and minor or secondary faults which run in almost east-west or west-northwest, east-southeast direction. So the two best examples are this one and this one for that. So if we simplify this map and put also the direction of the GPS vectors, is this red vector here, we can extract some conclusions on the kinematic character of the zone. So the GPS vectors show actually the direction of stretching. So what we see here is a direction of stretching which coincides with the direction of rifting, is at roughly 30 degrees angle in respect to the direction of the rift itself. So this drives us back to the nice model of oblique rifting of Whitsack and Jameson, which is shown here as a drawing, which says that in oblique rifting of this type with 30 degrees angle between the rifting direction and the rift axis, then we expect a dextral horizontal component along the northeast-southwest direction faults and an extensional character along the east-west trending fault zones. So what we think and we conclude is that this Santorini amorphous zone is actually a shear zone which displays dextral horizontal movement and in northeast-southwest direction and extension in northwest-southeast direction. The data that we have allow us to propose a model for the evolution of the area, which, according to which this Santorini amorphous basin initiated in early Pliocene as a more or less east-west basin, east-west tending extensional basin, and then sometime in the boundary between Pliocene and Quaternary, or in the early Quaternary, a change of the geodynamic regime led to a reorganization of stress and strain, led to initiation of new faults that broke the older initial basin, gave rise to uplift of ridges, and enhanced subsidence in the sub-basins. So this, the lower sketch displays the situation as it is today, with the several sub-basins which are northward tilted, the uplift of the ridges, and also the occurrence of volcanic activity along within the Anidos basin. So, similar observations we had from the area a bit to the southeast of the Santorini amorphous zone, and in particular between Astipalea and Nisiros here. This is a seismic line shown here, and what we see, we have a very peculiar seafloor with multiple ridges and elongate funnels, let's say. And if we put the interpretation here, we come up with multiple steep faults which produce this nice relief here and this complicated structure here with extensive southward tilting, which is responsible for the creation of this, let's say, basin and range structure. That area, for that area, in the literature, there are conclusions and hypotheses which point to a sinistral shearing since, let's say, in the early 2010. So let's come up to the entire Aegean Sea. So this map shows the sum of all the faults that we have mapped in the Aegean Sea, and also all the sedimentary basins which display thickness more than 500 meters in Pliocene and Quaternary. So what we see here actually is that, again, the major category of faults runs in northeast-southwest direction. Then the second category displays northwest-southeast direction. And then there's a third category which strikes west-east. And this third category also includes the fault that has given the recent earthquake north of Samos in last October. Well, if we superimpose the GPS vectors and the faults that we have mapped, then we can start thinking what is the relationship between the direction or the strike of the faults and the direction of stretching. We proposed that the angular relationship between the strike of the fault and the direction of stretching may be responsible for the kinematic character of the faults. So we think and we propose that faults which strike parallel or subparallel to the stretching direction should display mostly horizontal component, while faults which are at a high angle to the stretching direction should display mostly vertical component. In that sense, okay, the deformation is also confined between the two major boundaries of the, let's say, Aegean microplate. The northern boundary, which is a dextral strike slip boundary, which includes Kefalonia fault, North Anatolian fault, and Central Greece, which in this sense is represents a kind of pull-apart basin between the two edges of Kefalonia and North Anatolia fault, and the southern fault, which displays a sinistral sense of movement. So what we propose is that the northeast southwest striking faults, which mark the majority of the faults in the Aegean Sea, represent the segments of larger fault zones like the ones which are shown here in black color, and they display in most of the Aegean, they display a dextral strike slip sense of movement. Interestingly, there is a zone which is shown here with a dashed yellow line, which separates southeastern Aegean Sea with sinistral sense of shear from the rest of the Aegean, which displays dextral sense of shear. Then the northwest southeast striking faults should work as conjugate faults to the previous ones, and then they display a sinistral sense of shear, and that was nicely proved with the Skiros earthquake some years ago there. And finally, we have the faults which are which strike east-west and display more normal character. Now, the question is, when did this deformation style established in the Aegean Sea? The unconformity that we saw earlier and with the age of somewhere in the boundary between Pliocene and Quaternary or in early Quaternary coincides with other major events in the broader Aegean region, like the initiation of fast subsidence in the Gulf of Corinth, for example, which is in early Quaternary. Also, the data that we have from the North Aegean Trough, which indicate major deformation since early Quaternary, and this also, as far as I know, is the case for the Marmara Sea. So we think that this type of deformation with a northeast-southwest extensive shearing was established in early Quaternary and is associated probably with the propagation and arrival of the North Anatolian fault in the North Aegean Sea. Thank you very much for your attention. I'm open for questions as you like.
Thank you, dear Dimitris Sakellariou. I think there are no questions in the question and answer room. Only Tunçay Taymaz sent us three very recent publications, both for the SLAP and the Aegean, published recently in 2020. I would like also ask if there is a last minute question. So thank you, dear Dimitris. The next speaker is